All right, so let's talk about the basic welding circuit and polarity. And we're going to start talking first about DCEP polarity, but we'll also talk about the two other kinds of polarity that we use called DCEN and, of course, AC alternating current. And we'll start with DCEP because in the SMAW process, which most of you are starting with in your classes, this will be the first polarity that we'll use for our 7018 electrodes that we're using. And this is a really important concept for you to understand because it has a lot to do with telling us where our heat will be focused in our welding process and just overall how our welding circuit actually works. And you'd be surprised how many people that you'll come across in industry who may not even know what polarity they're using with any given process. You come around a lot of people who do know this, especially experienced people or educated people who went to school to learn to weld. But you will come across a lot of people who have no idea what polarity is, who are working as welders out there. So it's something that's really important for you to know. Okay. So we're going to talk about DCEP, which is also known as reverse polarity. That's kind of the more old school way of saying it. The nice thing about these acronyms is that they tell us right in the name, direct current electrode positive, how to hook up our leads in order to have the proper polarity. So in this case, direct current electrode positive means that our electrode, in this case, our stinger and our stick electrode, should be connected to the positive terminal. Okay, so DC plus, DCEP, or reverse polarity. Okay, and you'll see why it's called reverse when we get to explaining DCEN. Okay. So just bear with me on that for a second. So DCEP polarity. The thing to understand about polarity is that our current is always going to travel from negative to positive. Okay, so it's always going to travel from the negative terminal through the leads to the positive terminal. Our circuit's going to go in that direction. Okay, and that has a lot to do with where our heat's going to be focused. And I'll show you what I mean by that. Okay, so our current is traveling this direction. In this case, our electrode is hooked up to the positive terminal and our ground clamp is connected to the negative terminal. So our current's going to travel through our ground clamp lead, into our ground clamp, into our base material or our workpiece, and then it's going to go make the jump across in the arc zone to our electrode, travel up our electrode, and back to the power source. And it's going to continue in this direction. Okay, so always negative to positive, just like your attitude, right? Negative to positive. So what actually happens if you look in this arc area is that when the current makes the jump across in this arc from one terminal of the arc to the other, it encounters and creates resistance on this side where it's going to the other terminal of the arc. And that's where it's going to generate most of its heat. Okay, so in DCEP, it's making the jump from the base material to the electrode. That means that around 70% of our heat is going to be focused in the electrode. So in this case, these electrodes, the 7018 electrode, is designed to be used with DCEP polarity. Okay, so it is designed for it to work properly, to get good penetration for structural applications, stuff like that, with this polarity. So that's why it's really important for you to check the way that your machine is set up and make sure that you're on the proper polarity for what you're actually doing and the type of process that you're using and the type of electrode, in this case, for SMAW, that you're using the right one. Okay? So that's another thing to consider about DCEP polarity with stick welding is because this is generating heat by resistance, is that if you increase your arc spacing okay, and you're really long arcing that weld, you're actually increasing the resistance and your arc's going to get hotter. It's also going to get harder to control because it starts to wander around and get really erratic, but it's going to get much hotter and more erratic, and it's going to create undercut, and it's just going to be harder to control. So we want to try to keep that consistent as that electrode is burning away, right? Some of you may have already experienced this, okay? So that's DCEP polarity. Now, if we were to switch these terminals, then we would be welding with DCEN, right? Electrode negative, because then we would have the electrode connected to the negative terminal, right? So then our heat would be different, right? It would be traveling through the electrode, making the jump across to the base material. So then more of our heat would be focused on the base material side, okay? So this is important for some processes because, for instance, TIG welding, right? TIG welding on steel, stainless steel, is going to be using DCEN polarity. And that's really important because we don't, in that case, we don't want the heat focused on our tungsten electrode, which is non-consumable, right? Because then if our heat's focused on the electrode, you're going to start to see that electrode change shape or disappear up into the cup. We want the heat focused the opposite way for that process, which is in the base material, and be able to keep the shape of that non-consumable tungsten electrode nice and neat and sharp, right? And be able to focus that arc into the base material. So in that case, we would be using DCEN polarity. And that brings us to our final polarity, which is a type of current, alternating current, which means that it would actually change direction, change polarity, a lot of times per second. The standard would be 60 hertz. That means times per second. It would be switching back and forth. Our inverter machines are usually about 120 hertz times per second that it's switching between DCEP and DCEN. And that can be kind of confusing, at first. And, we can get into that later when we get into AC TIG welding on aluminum and that sort of thing, what the different sides of the polarity do in the arc zone, okay? But for now, I just want you to know the basic, movement of the current and, what they're each used for, and basically just make sure that you know enough to be able to set your machine properly. If you're given a WPS and it says your polarity is DCEP or DCEN, okay? So hopefully that helps you out, and we'll see you next time.